Welcome to my surprise Sunday stream. I wasn't expecting, I thought I might be able to, but I wasn't really counting on it, but I can. So here I am. I am going to work on day 12 of Advent of Code. Let's transition over to my screen here, and we can take a look at what day 12 has in store. So day 11 was pretty straightforward. It didn't take too long to do, and I was pretty happy with the solution. We are seeing a lot of relatively easy problems this year, except for the one with the digits, which I can't remember if that was that 8? Yeah, 8 was the digit one. That was a little tougher, but the rest of them seem to be pretty straightforward. Let's see what this one has. Day 12, passage pathing. With your submarines, subterranean subsystems subsisting suboptimally, very clever. The only way you're getting out of this cave anytime soon is by finding a path yourself. Not just a path. The only way to know if you found the best path is to find all of them. Really? Okay. Fortunately, the sensors are still mostly working, so you build a rough map of the remaining caves, your puzzle input. For example, start A, start B, A, C, A, B. This is a list of how all the caves are connected. Okay. You start in the cave named Start. And your destination is a cave named End. An entry like B-D means that cave B is connected to D. That is you can move between them. All right. So the above cave system looks roughly like this. Star can go to capital A or lowercase b. Capital A can go to C, B, or End. Well, this says you can move between them. So it goes both ways. So these are bidirectional. Okay. Your goal is to find the number of distinct paths that start at start, end at end, and don't visit small caves more than once. There are two types of caves. Big caves, written in uppercase like capital A, and small caves written in lowercase like lowercase b. Okay. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. Oh, that's the twist. Okay. I was thinking, okay, we just do a quick breadth first or depth first or whatever, but now we have a little twist on this where we can actually hit a cave more than once. So all the paths you find should visit small caves at most once and can visit big caves any number of times. Given these rules, there are 10 paths through this example cave system. Blah, 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 blah. Each line in the above list corresponds to a single path. The caves visited by that path are listed in the order they are visited and separated by commas. Okay. Note that in this cave system, cave D is never visited by any path. To do so, cave B would need to be visited twice. I see. Yeah, start B, D, and then you can't go back. But you can go start A, C, and then go back to A because it's an uppercase A. Okay, here's a slightly larger example. We got 2 letters now. Finally, this is an even larger example that has 226 paths through it. How many paths through this cave system are there that visit small caves at most once? All right, let's take a look at this. Oh, I thought this was going to be hundreds of lines long, but it's pretty short. Okay. Still something about the same length as 226. This might be a little longer. No, it's about the same. I don't know. All right, so I guess we'll first start. Well, first we'll start by setting up our quick fix list. We're on day 12 now. And then we're going to do the make dir. And then we're going to do the edit. And then we're going to put the pump on day 12. Make sure that checks, make sure that runs. And we see day 12. We're good to go. Okay, so the next thing we're going to do is to parse all this. So I'm going to grab this line to read the file. I'm going to grab this line to read the lines in. And I'm going to change this here to be test. It looks like we have multiple tests now, right? We have this little guy here, And then here's a slightly larger example and then a bigger example. So what we can do is just have, I'll say test 1, and then we can read in other tests. I think we can just split on dash, and then we can have a map, right? So we'll need hash map, right? And the hash map will contain a mapping basically of start and ends. So what do we want to call it? I don't want to call it map because that's too simple. Caves, and it's a hash map, and start. So start is going to be the key, or the left side is going to be the key, and then the values, there could be multiple values. So I think we want to go from string to a vector of strings, right? And then hash map new. I think this would work. And then we can say for ln lines, let's split equals l dot split on the minus sign. The from is going to be the split next unwrap, and 2 is going to be split next unwrap. And then we just need to say caves insert. Oh, we need to be able to append entries to existing entries. So I think it's cave entry from or default, right? And it'll create a default vector which is empty, and we'll just say push 2. And then we have to do, because it goes both ways, we have to do it the other way. Caves entry 2 or default push from. And that should check, although we should get warnings. It doesn't check. Oh, I have to toString it? I have to toString all these guys? 2.toString. Okay, so that checks. Let's print them out just to see what they look like. Actually, just say from to in caves, println, and the from is going to be a simple thing, but the 2 is going to be the array. All right, and this will check, but it won't work because I never created the input file. Input test 1 day 12. So let's copy that. Paste it here, save it, and let's try running. All right, so did this work? We've got end goes to A and B. Yep. Start goes to A and B. D can go to B. B can go to start A, D, or end. Capital A can go to start C, B, and end. And C can go just to A. Yeah, okay, so I think that worked. And now we're going to do another depth first search, I guess. Yeah, this is the advent of code of depth first searches, because we did one yesterday for the was it octopuses yesterday? I forget now. Yeah, the octopuses were yesterday, and we did a depth first search. Although, like I said, the twist is going to be we can visit things twice. And I did this iteratively, so why don't we just change things up a little bit and make it, I'll call it count visited. And why don't we make it, why don't we do recursive way this time? Just to make things different. So we're going to count visited, and we have the caves. I put ampersand there, but it's caves. And this is going to be a just a hash map from string to vec of string, although I can see myself having to type this many times, so I'm going to make this a type. Let's put that up here. Come on, there we go. So type cave map, cave path is this, And then we'll just say cave path. And caves is a reference to a cave path. Okay. And we're just going to return a count. So now what we need to do is keep track of the path, right? Or the ones that are unique. I'm trying to think about the right approach to this. We want to have my brain is getting stuck. We want to have a visited, and we want to have the resulting path. So let's create another struct, pather, which has a visited of a hash set, and that'll just tell us, oh, we want to do string, yeah, which ones were visited. And let's import hash set here. And then we want to have whatever the current path is, so we can print it out, which is just a vector of string. All right, and so now what we do is we'll create a brand new one. Path walker. There's a pather with a visited hash set new and a path of vec new. Right, and then now we're going to just start. We're going to say count visited from. This will be our recursive function. We're going to start at start. We're going to pass in the path walker. We're going to pass in the cave system. And that's all we need. And that'll return that. So now here comes our recursive function of count visited from. And it takes a starting point. Oh, let's not call it start because we're going to recurse down through it. So I'll just call it our current step, whatever step we're on. And it's a string. And then we have a walker, which is a mutable pather. And then we have the caves, which are the cave path. And that's going to return a usize. So now we're going to just obey the depth first search thing. So if we're on the end step, so if step equals end, then we're done. We can just print out the current path that we're on. So println, I'm just going to print it out for now because I want to see what they look like. And with the sample output, it's not going to be too bad. So that's just our walker.path. And then return that we found one path. Right, so if we hit end, there's one path that got us here. And we're going to add them up next. So we're going to have a count. And then and we're going to go over each one of our cave paths and see if there's a path from where we are to where we want to go. So for next, I guess, in caves get from our current position, which is step, and then we'll unwrap that. And now I have next should be this vector of twos, right? All the places we're going to. And if it's uppercase, right? If it's uppercase, then we want to use it because you can visit an uppercase cave every time. If it's not, if it's visited, oh wait, that's what we need to do first. Before we even do anything, we have to say that we're visiting it. So we have to say walker.visited entry of step or default Goes true. Oh no, this is a hash set. We're just inserting it. Walker visited insert. I don't know what I was doing there. So we insert that, and then we want to push our current path on there as well. Right, and that way when we call the next recursion, this walker will have the full path that will print out. And then we'll undo those at the end. So we're going to do blah, blah, blah here. And then at the end, we want to basically pop walker.remove, visited, remove step. That should work. And then we're going to say walker path pop. And we don't need to unwrap it because we're just popping it off. And then we're going to return this count, which we're going to generate here as we go through the blah, blah, blah stuff. And what is the blah, blah, blah? This is just a basic depth first search with a twist. So it's either if it's not visited or it's an uppercase, then we're going to call count paths again. Right. If so, next dot chars, so dot next. Right. We want to grab the first character, unwrap it, and see if it's uppercase, or if walker not walker visited contains next. Right, so if we haven't visited yet or it's uppercase, then we want to say count plus equals count visited from next the walker. I think we just do that, and the caves. And this will take care of inserting and pushing. This will take care of the removing and popping. I think that's all we need to do. So if it's uppercase or we haven't visited it yet, then we want to visit it and see if we can get to the end from here, from this location. All right, let's see what doesn't check. Oh, end like that. What else? Step. Oh, all right, I have strings in there. Okay. So this probably also has to be two string. Is uppercase. All right, that checks. Oh, there's 4 warnings though. Oh, because I'm not calling count visited. All right. I don't know why there's 4 warnings. Println day 12 part 1 is going to be count visited of our caves. This just need to be mutable because we're going to be mutating it. Oh no, we don't need to mutate that. Oops. We don't need to mutate that. We need to mutate the walker. The caves can stay the same. Okay. And I messed something up. I didn't put a close there. And that doesn't have to be there. Nope. Expected reference found struct hash map. Yeah, so I put that there, and then what was the error? Oops. Caves is moved, so I do need to put a reference. Caves is moved due to the implicit call of into iter in the for loop. Okay. It's saying do this here. Oh no, for from 2. Oh, I was looking at the wrong thing for from 2. Yeah, so it was happening here. So we don't need this anyway. Okay. Okay, no errors, no warnings. I'm going to run it here, taking the chance that it's not going to go into an infinite loop. And we came up with an answer of 10. And these are all the paths we dumped out. I forgot to add n to the end, but that's okay. We don't have to worry about that. This looks right, and it was expecting 10 paths. So I think we coded it correctly. Let's try the slightly larger example. Input test 2, day 12. Paste that in. And then change this to day 2, or test 2, sorry. And then run that. And what are we expecting? I'm going to stop printing these paths out. 19 is what I got. 19. Okay, so we're on the right track here. Those are the 19 paths. Let's use this as test 3. Input test 3, day 12. Save that, and then I'm going to change this thing here so it doesn't print out the paths. Run it. Oh, I forgot to change it to test 3. Run. 226. Yes. Okay, so now we can grab our puzzle input. Copy. Oh, it's input, day 12. Save that. Change this to input. Run it. And we got 4241. That's pretty long for the input, but it worked, so it's right. Okay. So that was a straightforward depth first search with a twist. Straightforward with a twist. So if it's uppercase or we haven't visited, then we can go ahead and visit it and do the same thing recursively. So that's the recursive solution, as opposed to yesterday we did the iterative solution, and I think there was another one we did an iterative depth first. Thank you, the Swiss. Appreciate that. I have no idea what part 2 is going to bring. Let's check this in. First check with Clippy. And push this up, git add source and inputs. Did I do that right? I did that right. Git commit -m day 12 part 1 git push. All right, so part 2. What's the twist on part 2? After reviewing the available paths, you realize that you might have the time to visit a single small cave twice. Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice, and the remaining small caves can be visited at most once. However, the caves named start and end can only be visited exactly once each. Once you leave the start cave, you may not return to it, and once you reach the end cave, the path must end immediately. Okay, that's actually good, that last part. That way we can just do the start end and not worry about it. Now the 36 possible paths through the first example above are this. Presumably we go through, so we go through this small one here and this small one here, but no more times. And then sometimes we just go through it once anyway, like here. Okay, all right. The slightly larger example above has 103, and the even larger available has 3509. Okay, how do we want to do this? How do we want to approach this? Because now we have another condition, right? Instead of just checking to see if it's uppercase and visited, we now need to keep track of how many times we visited the cave. Okay. So instead of using a hash set here, we can create a hash map and just keep a running total here, and then increase the knowledge here, right? Of when we want to count visited from. So now this is no longer hash set, this is a hash map, which goes from string to usize, right? That way we can keep a count. And instead of doing the insert here, we do or default. and say plus equals 1. Right? And I want to do this without breaking this current, being able to print day 1 and day 2. I mean, I know a lot of people, when they do this for speed, they just get day 1 solved and then they just rip out whatever they don't need for day 1 and put in day 2 and then run that and then they're done. I still want to be able to run both days. So if we do this, then we need a star in front of there, right? That's what we learned from the other day. We need to put a star there. Right now, I'm just going to rework this such that we can check, right? So if it's this, or if Walker visited contains next. So it's not contains next. What we want to do is say get. And say if the entry, because it might not exist yet, or default, right? And that'll be 0, is less than, less than 1 or equals 0. Right? Right. I think so. If the entry is 0, then we want to call this. Let me indent that one more line just so I can read it. Maybe line these guys up. I don't know. How does that look? All right, so this is saying if we have not visited, right? So if it's 0, then we want to call. And then instead of doing a remove down here, we have to actually subtract 1. So we'll put the star there. We'll say, what's entry or default minus equals 1? And now the question is, does this come up with the same number as 4241? Does it check first? It does not. Oh. This has to be a hash map. And that doesn't work. Visited. Entry. Like this. What was I doing? Or default. And it doesn't like this. I wonder why it doesn't like it now. Oh, because it's actually copying it over to string. Okay. Nope, didn't mind it there. No implementation for mute usize is equal to integer. Oh, I got to start it again. All these things need to get started. And then what's the next one? Oh, this has to be a toString. And I forgot to put parens around there. Wow. Okay. We have 3 warnings. We're not using hash set anymore. I have double semicolon there. Okay. I'll fix the double semicolon and rip out the hash set. Like that. All right. So that works. Does it still come up with 4241? It does. Okay. So I didn't break it. That's the good news. Now the question is, can we modify this so that we can check? How do we know what we're checking? Because what we want to do is for every lowercase, one, we want to be able to do double. So instead of checking to see if it's 0, we want to check to see if it's less than 2. But just for that one entry. We can pass it in as an optional cave location to double check, right? What if we do that? We'll call it a double and make it an option. I'll probably make it a reference to an option string, right? And then else if let some d equals double, that means we have a double cave. Then we want to say if this is less than 2, then we also call this function. Now all of my formatting is bad. There, that looks better. Okay. Right, so, oh, if let sum d is double, and then we want to check, is d equal to the current one that we're looking at, and we're still less than 2. Then we can do another count visited. This might work. Oh, hi, Roger. Kind of looks like every other language. Yeah, well, I mean, it looks like it's very C-like, right? Which is JavaScript, which is, you know, Java, which is... But it's different enough that I'm enjoying it. All right, so now what we need to do, because now it's broken, and the reason I did option is so I could put a none up here, actually a reference to none up here, and this should still check. Of course it doesn't. I supplied 3 arguments and I need to supply 4. So this needs to get the double, and this needs to get the double, and that checks. Does it still give us 4241? It does. Now I need to write a count double visited. So out of curiosity, Roger, what languages are you most comfortable writing in? So let's see. What do we need to do for this? We still need this walker thing, right? So maybe we can refactor that after this is done, after I get it working. And then we need to say for each path, we want to look to see if it's a lowercase. Oops, that's annoying. If we want to look to see if it's a lowercase and then pass that in as a sum. And if it's not lowercase, then we just pass in a none, and then we just want to add up all of the resulting paths. Right? I mean, I am trying to think here, because we might end up with duplicate paths. I don't know. Well, let's see. Let's see what happens. If I say for C in caves keys, right? We're looking at just the keys of this. We're looking at each one of those. And we're going to say if C is not equal to start, right? Because we don't want to visit start. General Nova says, I'm good at writing in English. Okay, well, that's good. That's not the kind of language I was meaning, though, but I'm sure if you wanted to learn how to program, there's plenty of tutorials out there. All right, C is not start and C is not end. Then what are we going to do? We're going to check the first character. C chars next unwrap, like we do. And if it's is lowercase, then we know we're dealing with a lowercase cave that we can visit more than once. So we can just say count visited from. Oh, we need a count. I need a running total here. And just say count plus equals count visited from. We're going to start at start. Path walker. Oops. And then the caves, and then we're going to give it a sum of first, right? And then else, if it isn't, we're going to do this, except we're going to pass in none. And then we're going to return count. And then we're going to call it up here. Change that to 2. Change this to double visited. And see if it fails. It does fail. Oh, do I need to toString it again? Yep, I need to toString it again. All right. Oh, I shouldn't have done it on the actual input. It came up with a number, but I want to, before I put that number in, I want to test. Let's put in some test data. Since it's available to us, we might as well try to test it. And this was supposed to be what? Bum, 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 bum. Oh, that's the first part. Here's the second part. Oh, 36. Yeah, I think this is because I'm coming up with paths, duplicate paths. Whoa. What's the best way around this problem? I can cheat and just use a hash set, right? Because we have the path. We have the full path, and if we just put that into a hash set, It's a little sloppy, and then I'll have to put the hash set back, but it might just work. The 1 in a million shot, but it just might work. Okay, let's add that here. Unique hash set of string, right? Because what I'll do, maybe this is the clever part. What I'll do is I'll convert it into a string and say, now we have a path that's unique. So we can say unique insert format of, got the opening quote, of Walker dot path. And then instead of returning a count down here, we'll just say, well, we will return, oh, this is going to insert it into the global thing. So yeah, this is getting a little ugly, but instead of returning count here, then we'll just return the unique len without the semicolon, right? So what we're doing now is for every path we find, if it's a duplicate, then the insert will just overwrite the existing one with the same string. It's a little slow because we're going to be doing a lot of string stuff, but it'll get us the answer, and that's the important part for, oh, it's Walker, path, Walker. The point is to get the answer, right? We still have 3 errors. Well, this one's just called Walker. And what's this error? Oh, I didn't create a new unique. You know what? Actually, I can just say default, right? And just derive default here. Because I'm just creating empty hash maps and empty hash sets. Why don't I do that? Okay, we still have 2 warnings though. Let's see what the warnings are. Oh, now we're not using count anymore. Right, because we're not returning it. We're just adding them up. We don't actually need, all we're doing is setting up the unique. So we can get rid of that. Does this come up with 36? All right, so here we go. We got 36. It's a hacky solution, but it works. Let's see if we can get 103 with test 2. That is not 103. How did I get 36 for the first one, but not 103 for the second one? Try test 3. Oh, I'm getting 226 for both now. And test 1 worked? I got 10 and 36. Huh. Okay, so there must be a bug somewhere else. Let's take a look at our code. Maybe there's some things I'm not taking into account here. So if it's uppercase, then we're going to do this count visited from, right? If it's equal to 0, then we're going to do a count visited from because it's unvisited. And if we're doing a double, oh, I never incremented. No, I did. I incremented it right here. All right, so let's print out what we got. Double checking this guy, and this is first. And what we're going to do is and what I want to do is just print out the path. Each path it finds. That way we can take a look at it. Walker.path. All right, let's run that. Okay, so this was part 1. So part 2 is double checking B. So we see 2 B's in there, 2 B's in there. Two B's in there, 2 B's in there, B, A, C, A, B, end, right? Because it goes to end. And then we'll do double checking C and double checking D, and that all works, and we got 36. All right, so let's do the same thing with test 2, because that one was broken. All right, we only got 19. This is a lot more than 19. Although, okay, you know what we should do is write this to a temporary file. And then we can edit that. And then just look for uniques here. Oh, that's part 1. We don't care about part 1. I'll delete that. Delete that. Delete that. And what we can do is just say sort unique-c. So it came up with the five of every single path. And I don't see any doubles in here, right? Are we checking for double incorrectly? It's an option string, and we're checking for string equality. And I thought I was seeing doubles in the other one, wasn't I? Double. Looking at this as a double path. Okay. Ah, yeah, so that's what's going wrong. And this is why test 1 works. Okay, so that explains, at least gives me a little understanding as to what's going wrong, right? What's happening is it's able to do it if it's a single character, but it's not able to do it if it's a double character. Right? I mean, yes, that's what's happening. And if we look to see, oh, double checking D, that's why. Why is it doing that? Double checking S. S, K, D, S. It's just looking at the first. Oh, first is. Oh my God. All right. So we didn't actually want that. We didn't want first 2 string. We wanted C here. And do we have to 2 string it? I don't know if we need to 2 string it. We want to pass in the whole thing. And now let me delete these prints, because I don't want to see all that output. I think that might be the bug. 19 and 103. Okay. That was a pretty dumb bug to put in there. And this should be 3509. And it is. All right. So now let's test it with the real input. I'm glad I tested with the test data before I put that other number in. All right. And we come up with a very long execution time. It finished. It took a long time to look at that. It took 5 seconds to come up with an answer. That's the right answer. Woohoo! All right. Let's see if Clippy's happy. I'll get this checked in before I make any day 12 part 2. Oh. Push that up. And then, is there anything we want to look at with this code? Yeah, I mean, it's just a basic depth first search, except for, oh, this looks really ugly. I don't like this formatting at all. Thanks, Cargo Format. I guess I could split these up into 3 separate ones. It means a little bit of duplicated code, but it'll look less ugly. Let me do that. And then you just say else if this guy. And just do the same line here. I think that looks a little less ugly. We got 3 of these count plus equals count visited froms, but I'll live with that. Let's see if Cargo Format's okay with it. Oh, I messed something else. If same then else is the same as this. Oh, it's complaining that the if has identical blocks. All right, I'll put it back. Or and of course I messed it up. Okay, and then format that. And one more look. All right, so this should be unchanged. It is. I guess I could have just done a checkout dot. Yeah, unfortunately we can't combine these lines here because the if let, you can't put extra things. You can't say and on there. It won't let you do that. Maybe a newer version of Rust will let you do that. Yeah, I mean, it's just a basic depth first search. We've done it like 3 or 4 times now in this advent of code, but it does the trick. Comes up with the answer. It's very slow. Let's see if the release is any better. It should be less than, it's less than a second, but it's still very long, a very long search. So there's probably some optimizations we can make to speed things up. All right, let's take a look at the leaderboards. Personal stats. Ooh, I was a little too slow for breaking 20,000. Dang. All right, that's okay. We got it done. We're all good and happy, and we finished it in less than 50 minutes. Thank you everyone for watching. Let's see if there's anybody streaming that we can raid. I see that Prime is up, but that's okay. We can go raid him. Let me pull him up first on here so I can see what he's doing. He might be doing Advent of Code. Yep, he's doing day 11. Okay, so why don't we go raid him? But meanwhile, thanks again everybody for joining me here. I had a good time, and I hope to catch you tomorrow for day 13. Take care.